first thing you do as part of this module is turn on this ventilation system shown here with just a flick of the switch. What this does is it creates some negative pressure just in case some gas accidentally escapes from the manifold. You won't be exposed to it. Now you have to set up the manifold itself. The right half of the manifold is usually in the fume hood, so you have to take that and attach it on the right to the vacuum pump and on the left to the rest of the manifold. And this is the liquid nitrogen trap that prevents any gases from getting into the vacuum pump itself. Here's how you turn on the vacuum pump and pressure gauge, just right here. And after you do that, you want to open up this valve so that the whole system is under vacuum. Very quickly, you want to go ahead and add liquid nitrogen to the door. The liquid nitrogen, when you pour it into a warm container, it bumps a lot, it kind of gets everywhere, it's a little annoying. Just pour slowly, patiently, and fill it to the top. And you might want to wrap a little aluminum foil around it to keep the liquid nitrogen from boiling off before the end of the class. Now we're going to weigh out the calcium carbide. 0.4 grams, maybe a little bit less, don't go over, that's a little dangerous. You see here it's about the size of half a thumb. And you take that and you're going to add that to the reaction vessel, which is usually also in the fume hood, as so. And then you're going to stopper it with a septum, which are held right by the manifold. It's a little hard to fold over itself, but as you can see it can be done. And then go ahead, connect it to the manifold, clamp it, and go ahead and open the valves to put it under vacuum. The reaction is very exothermic, so it needs an ice bath. You use an ice bath when you're reacting with D2O, but a salty ice bath with H2O. H2O is a little bit more exothermic. Now you see, we actually accidentally made a mistake when filming this demo. We're going to react the calcium carbide with D2O, but we accidentally made a salty ice bath, and that's actually too cold for that. I'll show you what happens as a result. You'll see that momentarily. You want to submerge the reaction vessel to about half. Next, you want to add the FTIR cell itself. If it needs a little bit of grease, just go ahead and add some, and maybe add some to the manifold as well. And whenever you're adding anything to the manifold, maybe you want to give it a little bit of a twist. That helps make a better seal. And always, anything added to the manifold, put a clamp and support from beneath with a ring stand. Now, open up the IR cell to vacuum. You need to do that because we have to take a blank spectrum in the FTIR. So just open it up, let the pressure go down, and after that's happened, close it off, top and bottom valves. And here's a funny thing, you can't just pull the IR cell off. It's too strong. There's a little vacuum between it and that second valve in the manifold. If you try, you'll see here, you just don't have the strength. So what you do is you actually roll the IR cell off the manifold. It's very easy. So you go to the FTIR and put that in its cradle. They're designed to work together, snaps right in place. Now notice how those valves are on top and facing you. It's designed to be like that, so do it that way. After you close the chamber there, wait for 10 minutes for the chamber to be flushed with nitrogen. Now, we can't really show you what we do with the computer because it just doesn't come across in video. Just follow the procedure in the lab manual. Okay, we've done the background scan. Let's connect it back to the manifold and we're ready to flush it with acetylene. So we've connected back to the manifold. Open up the valves. And now we're ready to make acetylene. In this case, we're going to get D2O. And we're going to add some about 3 mils, and we're going to use the D2O syringe. There's a H2O syringe as well. Don't mix those up. That would cause a lot of problems. So we fill up the syringe. But before we inject, we got to double check that the valves are set correctly. Here's what you do. That one's open, 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 but this one you need to close. That's because we want to fill the left-hand manifold with acetylene, and thus we need to cut off the pull of the vacuum in the trap. So we're going to close that. Once we do that, we're ready to inject the H2O or D2O into the reaction vessel and create acetylene. I probably should go through the center of the septum there. We're a little off, but it doesn't matter. So we've injected the D2O, and as we look, there is a fairly violent reaction going on. And guess what's bubbling out? That's acetylene, filling the whole manifold. the pressure will start to rise. Now, as I stated, we made a slight mistake. When we were filming this, we realized the pressure wasn't rising very fast. We looked inside the vessel and saw, because we had such a cold, salty ice water bath, the D2O in the reaction chamber froze and is not reacting. As a result, we had to lower the salty ice bath, and then the pressure started rising faster. And we were careful to make certain that the vessel didn't get too hot. Here we still see that the reaction is going on, but it's clearly almost over, and the pressure is getting much higher to about 100 torr. That's great. That's about perfect for taking the FTIR spectrum. Just wait until the pressure is stabilized and the reaction is over. Now close off the IR cell as before, and before you take it to the FTIR, you have to do one more thing. Close off the connection to the vacuum pump and open this guy up. So basically what that does is it pulls off any water in the left half of the manifold into the vacuum trap. You only need to wait a minute, wait till the pressure is down to say 20 or 30 torr. What you saw there was a little abnormally low, and then go ahead and open up the vacuum pump valve. We already sealed off the IR cell before we exposed the rest of the manifold to vacuum just a moment before, so that's ready to be rolled right off the manifold, and you take it over to the FTIR to record the actual acetylene spectrum. Again, it fits back in its cradle, and remember when you close off the chamber to wait 10 minutes for nitrogen to flush the system, and just follow the manual procedures for working with the computer to record the spectrum. And now it's time to shut down. This is not trivial, so that's why we've included this in the video. You're going to add the IR cell, flush with acetylene as before. You're just going to attach it to the manifold, use the vacuum pump to remove the acetylene. It's perfectly safe. You monitor the pressure at the very end to make sure it's down to just a few torr, and then you can turn off the vacuum pump. What's a little bit harder is the reaction vessel. It's quite messy right now, and you need to clean this so the next person can use it. So, of course, we're going to seal off the vessel with these two valves. Remove the clamp. Make sure you're turning that the right way. And take the vessel over to the fume hood. When you open this up, you're going to hear a little bit of a swoosh, and you may notice that the vessel is filled with some kind of calcium hydroxide smoke, so you definitely want the sash between you and it. And all you're going to do is remove that septa and rinse several times with water, get all that calcium hydroxide out, and pour that into the FTIR waste container. You're going to need to demonstrate to the TA that the system is clean before you're allowed to finish with the lab. If you leave with a dirty reaction vessel, no points. Don't do that. You're done. Good luck analyzing the data. That's the hard part.